Okay? We're going to start talking about polynomials. You have heard a lot about terms. You've heard a lot about like terms. You've heard a lot about unlike terms. So we're going to add a couple more vocabulary words to your brain. The first one that we're going to add is monomial. A monomial is one term. It's one term. It can be like 2x squared. It can be x over 2, 2/3 x squared times y to the third times z. A monomial contains variables with whole number exponents. You are multiplying or dividing within the monomial. You cannot have a variable in the denominator, and you are not adding and subtracting. Okay? That is what a monomial is. It is one term. You can be multiplying within that monomial, and you can divide, but you can't divide by a variable. So you can't have a variable in the denominator. But that's what a monomial is, and it is one term. And you've been working with monomials for years. You've been working with monomials for years. Okay? A binomial is the addition or subtraction of two monomials. A binomial has two terms. So some examples that I have are x plus 3, x squared minus 1, x to the fourth plus 8. We are adding and subtracting, adding or subtracting two terms. That's what a binomial is. A trinomial is the addition or subtraction of three monomials. Three terms. I can have x squared minus 3x plus 2, xy plus x squared plus y squared. Those are both trinomials. Now, a polynomial includes all of the above. Okay? A trinomial is a polynomial. A binomial is a polynomial. But typically, we call something a polynomial if it's got more than three terms. Okay? If it has three terms, we call it a trinomial. If it has two terms, we call it a binomial. If it has 4, 5, or 6 terms, we call it a polynomial. But I want you to understand that monomials, binomials, and trinomials are just very specific polynomials. Think about a polygon. A polygon is a shape. Okay? A triangle is a specific polygon. But is a triangle still a polygon? It is. Okay? You can have a square. You can have a rectangle. Those are all polygons. They're just very specific polygons. So a trinomial is a specific polynomial. It's a polynomial with three terms. Okay? Now, the next thing that we need to talk about are like terms. You have been working with like terms for a very long time, but I want to remind you what like terms are.
I didn't get that.
I'm sorry?
I didn't get
Okay. I still see people writing, so we're going to hang here until people are done writing. Okay, can I go to the next screen, or do I still have people writing? Okay. So we need to have an understanding of what like terms are. We have been dealing with like terms for some time. I just want to remind us of the definition. The thing that we do with like terms is we combine them. Okay, we combine like terms. Like terms are terms that can be added or subtracted. They are always the same variable, but it also has to be raised to the same exponent. So if I have something like 2x squared plus 3x, even though my variable is the same here, these are not like terms because they are not raised to the same exponent. Okay? These are not like terms because they are not raised to the same exponent. To be a like term, it has to be the same variable and it has to be raised to the same exponent. So 2x to the third minus 1x to the third, those are like terms because they are raised to the same exponent. Okay? Another term that I want you to be aware of is coefficient. Coefficient is the number in front of your variable. So in our first one, 2x squared, the coefficient in front of that is the 2. Okay? In negative x squared, the coefficient in front of the negative x squared is the negative 1. Okay? What is the coefficient in front of x squared? 1. Okay? And when we are combining like terms, those terms, what you're adding and what you're subtracting are the coefficients. That's what you're doing there. Okay? And we've dealt with like terms for a while. I just like to review that. Okay. Can I move off of this screen? Okay. I'm going to go backwards a little bit, and we're going to talk about the degree of a polynomial. Now, if you look at this right here, I've got x plus 3 equals 2x minus 1. That is something that we have been solving for a while. Okay, we know how to solve that. That is called a linear equation. It is a linear equation. What is my x raised to right here? What exponent is my x raised to? I heard it. It's not raised to 0. It's actually raised to 1, okay? So this is x to the first. We just don't ever write down x to the first, okay? That 1 is assumed, okay? So this right here has a degree. Its degree is 1. When I am looking at the degree, I'm looking for its highest exponent. The degree of a polynomial goes by its highest exponent. Okay? So, I want us to look at the next one. The next one is what we call a quadratic. And we're going to do a lot of work with a quadratic. That does not look right. Quadratic. Maybe it's a D. Okay? We're going to do a lot of work with a quadratic. We're going to factor. We're going to do some solving. This is a second degree polynomial. Okay? This one is a degree of 2 because the 2 is my highest exponent. That's what I'm looking at. It doesn't matter that this term right here has an exponent of 1. Okay? It only matters that my highest exponent is 2. Yes?
Are we using the quadratic formula at all?
Yes, we will. But that's a while. Okay? Okay? So, my next one is a cubic, and it is a degree of 3 because our exponent is a 3. Okay? X to the third, a cubic. X to the third. Okay? Now, here, my very last one, I've got this right here is a monomial because they are being multiplied together. So this is a monomial, x to the third y, and xy. So I have 3 monomials added together. What does that make this? It is a polynomial, and even more specific, it's a trinomial, okay? To find the degree of this, I have to find the degree of each monomial. Here I've got an x and I've got a y, both raised to an exponent. I have to add those together for each individual monomial. X squared y to the third, if I add the 2 exponents together, I have a degree of 5. Here I have x to the third and I have y to the first. When I add those together, what do I get? 4. Here I've got x to the first and y to the first. When I add those together, what do I get? Okay? For this trinomial, to find the degree of this trinomial, I'm going to take the degree of my highest monomial. So what is the degree of this? 5. The degree of this is 5. I don't add the degrees of each monomial together. I look at the individual monomials. Okay? Students typically do okay with the ones that just have one variable. It's when we bring in 2 variables that students get a little bit more confused. Okay? So let's try some of these. I have 7xy and 6y. This is a binomial because I have 2 terms. My first term, or my first monomial, is 7xy. What is the degree of 7xy? 2. Okay, that's correct. What is the degree of 6y?
1.
Good. Okay, what is the highest degree there?
2.
2. So this binomial has a degree of 2. Okay, what about 5x squared minus 7x minus 2? What is my highest degree? 2. That is a quadratic. So this one also has a degree of 2. Negative 12 is what we call a constant. Okay, it is a constant. Does it have a variable? No, it doesn't have a variable. Does anyone know the degree of a constant?
0.
It is 0. Okay? The degree for this is 0. It is a constant. Okay? You can think about this as x to the 0 power. X to the 0 power is 1. Anything to the 0 power is 1. We'll talk about that pretty extensively on Wednesday. And you'll be able to see how that is 1. X to the 0 is 1. So the degree of a constant is 0. Now for our last one, we have 5x to the third and y squared minus 6x to the third y squared. I'm going to look at this and I'm going to look at this. What is the degree of 5x to the third y squared? Good. What's the degree of 6x to the third y to the third?
6.
What's the degree of this binomial?
6.
Good. Good, good. Okay, so that's determining the degree. Can I move off this screen? Okay. Now what we are going to do is we are going to add and subtract polynomials. Okay, we're going to add and subtract polynomials. When we do this, I want you to think about 2 different things when we are doing this. The first question that I want you to ask yourself as we are adding these together, is there anything inside the parentheses that can be combined? Okay, so what we are looking for inside the parentheses, are there any like terms inside each individual parenthesis? So I'm going to look right here. Is there any like terms inside that can be combined? No. Okay? The second thing is there anything inside this one that can be combined? No. Okay. So the second thing that I'm going to ask, is there anything that needs to be distributed? Okay? Is there anything to distribute? Okay? So I am looking for something on the outside here and on the outside here. Is there anything that needs to be distributed? No. Okay? At that point, we can drop the parentheses. Okay? Once we have addressed these two things, we can drop the parentheses. So I have 4x squared plus 5x plus 1, and I am adding that to 7x squared minus 9x plus 4. Okay? Now I combine like terms. I have 4x squared and 7x squared. 4x squared and 7x squared is 11x squared. Okay? I look for my next set of like terms. 5x, negative 9x. What is 5x and negative 9x? Good. Negative 4x. Okay? Then I have positive 1 and positive 4. And what is that? Good. Now, I cannot combine anything else. None of those are like terms. I stop. Okay? One of the things that happens and one of the mistakes the students make is they don't stop right here. They're like, oh, I'm going to combine 11x squared and negative 4x. You can't combine those. You're done. Okay? Yes, sir?
When we answer it, do you want us to put it in order from greatest to least?
That is typically how you see it. You almost always. It's not wrong if it's not in order from greatest to least. But you almost always see it in order from greatest to least. Okay? Can we do another one? Okay. Here I've got negative 4x squared y plus xy squared plus 7x squared y minus 9xy squared plus 5x squared y minus 4xy squared. So I am combining 3 binomials. 3 binomials. Okay, so the first thing I ask myself, is there anything inside the parentheses that can be combined? Anything inside the parentheses that can be combined? And there's not. There's nothing inside the parentheses that can be combined. Is there anything outside the parentheses that needs to be distributed? No. Okay, so now I can drop the parentheses. So I have negative 4x squared y plus xy squared plus 7x squared y minus 9xy squared plus 5x squared y minus 4xy squared. So now I'm going to start looking for like terms. I have negative 4x squared y So I have to find terms that have the same exact variables raised to the same exact exponent. Okay? So everything that I combine has got to have an x squared and a y. So then I've got a -4, a +7, and a +5. Okay? What do I get with -4, +7, +5? Good. And then I keep the x squared and the y. My next set of like terms, I have an xy squared. What's in front of that xy squared? Good. So I have a 1 xy squared, -9 xy squared, -4 xy squared. What does that give me? Good. And then I stop right there. I stop right there. 8x squared y and -12xy squared are not like terms. I cannot combine them. So I stop. Okay? Okay. Are we ready to look at subtraction? Okay. So, here I'm going to ask myself the same question I did earlier. The first question, is there anything that needs to be combined inside parentheses? No, there are no like terms inside the parentheses. Okay? Now, is there anything that needs to be distributed here? Yes, we have to distribute the minus, and that is a huge place that students make mistakes. You've got to take this negative and you've got to give it to everything inside of this trinomial. Okay? So, what we have is we have 7x squared minus 2x minus 4. I subtract 3x squared. My +7 becomes -7x. My negative and negative becomes +1. So I have distributed that to the entire trinomial. Now I can look at like terms. So I have 7x squared and minus 3x squared. So that is going to be 4x squared. Okay, then I have -2x and -7x. That is going to be -9x. Then I have -4 and +1. And that is -3. Okay, and I can't go any further. I can't go any further. Okay, can I go to the next screen? Okay. Here I've got 3 binomials that I am combining. 3 binomials together. I am subtracting the second one. So I've got to distribute this minus only to the second one. Only to the second. So I'm going to go ahead and rewrite this. So I have 5a squared minus 2b minus 2a squared minus 4. Okay? Now, I'm adding -7b minus 3. I can write that as plus -7b minus 3. Some people prefer to just write one sign, and so they'll write minus 7b. It's okay. It doesn't matter which way you do it. They both mean exactly the same thing. So now I've got 5a squared and -2a squared. What is 5a squared and -2a squared? 3a squared. Okay, then I have negative 2b and negative 7b. So I'm left with negative 9b. And then I've got negative 4 and negative 3, which is negative 7. Okay? Can I go to the next screen? Okay. I want you to try this one. Okay? So I'm going to give you about a minute to do this one. Okay, we have to distribute. What do we have to distribute? Good. We've got to distribute the negative to this. Okay, so I have 4t squared minus 7t minus 1 minus t squared minus 2t plus 6. I gave that negative to everything in that trinomial. Now I've got 4t squared and minus t squared. That would be a 3t squared. Negative 7t and negative 2t is negative 9t. Negative 1 and positive 6 is positive 5. Any questions on that one? Any questions on that one? Okay, let me tell you about where students make their mistakes. Okay, when we are adding and subtracting monomials, the exponents do not change. Okay, when we are adding and subtracting, it's the coefficient, which is the number in front of that. That's where students mess up. Okay? Is they start adding and subtracting exponents. But when we are adding and subtracting monomials, they do not change. What happens, and we're going to talk about this on Wednesday, what happens is students remember when I've got x squared times x to the third. Does anybody know what x squared times x to the third is?
X to the fifth.
It's x to the fifth. Okay? X squared times x to the third is x to the fifth. What happens then is they remember this, and then when I've got 2x squared plus 3x squared, students will write it as 5x to the fourth. And this is wrong. That is wrong. Okay? The answer to this is 5x squared. So when you are adding and you are subtracting monomials, your exponent stays the same. It does not change. It stays the same. Okay? So all of the monomials that we added together, once we decided they were like terms, we added or we subtracted their coefficients. And that's the number in front. 2 and 3 are my coefficients. That's what we added. Okay? So I want you to start thinking about that as on Wednesday we move into our properties of exponents. And that's what we'll focus on Wednesday is our property of exponents. Okay? So this is where students make mistakes. They remember some things about properties of exponents and they apply them when we're adding and subtracting them. So when we are adding and subtracting monomials, the exponent does not change. The exponent does not change. Okay? Okay. Before Wednesday, you need to do one of two things. You need to read pages 114 through 117 in your book. Okay? Read page 114 through 117 in your book. Or Google exponent rules and print out a sheet on exponent rules. So we are going to focus on exponents. So we're going to be multiplying, we're going to be dividing, we're going to be raising a power to a power, we're going to distribute, we're going to FOIL, we're going to do all of those things on Wednesday. Okay? So I want you to go and I want you to look at those so that you can be exposed to them before we get together. Okay? Questions, comments, anything that you need from me? Okay? I want to remind you